Hello students, this is your solutions video for question 1 on the classwork number 1. So let's get started. The graph of the continuous function g, the derivative of the function f, is shown above. The function g is piecewise linear for -5 is less than or equal to x is less than 3, and g of x equals 2 quantity x minus 4 squared for 3 less than or equal to x less than or equal to 6. A, if f of 1 equals 3, what is the value of f of -5? B, we want to evaluate the integral from 1 to 6 of g of x. C, for -5 is less than x is less than 6, on what open interval, if any, is the graph of f both increasing and concave up? Give a reason for your answer. D, find the x-coordinate of each point of inflection of the graph of f. Give a reason for your answer. Alright, so let's get to work. So the first thing we want to do is if f of 1 equals 3, what is the value of f of -5? Well, we need f of -5, so let's figure out what's going on. What's the relationship between g and f? Because we have a graph of g. Well, they tell me that the function g is the derivative of the function f. So is means equals, so g of x is the derivative of f of x, which we also usually call f prime of x. So if g of x equals f prime of x, we can go ahead and say then that g prime of x equals f double prime of x. And now if we wanted to go backwards, we would have to say that f of x, because that's what they're asking for, f of 1 and f of -5, f of x is going to be the antiderivative of g of x. And this little table here is actually going to be very helpful and important for solving almost all of these questions. So we're going to go ahead and we're just going to take this and keep it over here so we know to have it for later. So if I have f of -5 and f of 1, we're going to have to do an antiderivative of g of x. So the antiderivative of g of x equals f of x. Now I can't just take the antiderivative of g of -5 because I don't have a function for where g is -5. So that's not going to work. But what I can do is take a definite integral of g of x starting with -5. And where is this going to end up? Well, I could pick anywhere I wanted it to end up, but I'm going to pick something helpful. The only thing I know is for where 1 goes. So we're going to end at 1. And this is going to be the antiderivative of g of 1 minus the antiderivative of g of 5. We said that the antiderivative is our f value. So that means the antiderivative from -5 of 1 of g of x equals f of 1 minus f of -5. And here we have created an equation that can solve for our f of -5. So we're going to keep him. And keep going. Give me some space here. All right, so we know we're going to try to find our f of -5, so that's not going to go anywhere. And our f of 1, we found earlier, they tell us is just 3. So now I need to figure out what is the antiderivative from -5 to 1 of g of x. Or if you remember back from class, we said the antiderivative of a function is the area between that function and the x-axis. So we're going to go from -5 to 1. We want this area here. And we can see that area is broken down into 3 parts. We have a square here, a triangle, and another triangle. And remember, when the area is below the x-axis, it's negative. So this area is a 3 by 3 square. So the area of our first section is going to be 3 times 3, which is 9. But it's a negative area because it's under the x-axis. The area of our second figure is a 1 by 3 triangle. So the area is 1/2 times base times height. And that'll give you 3 halves. And our final area is a 1 by 2 triangle, so the area is 1/2 base times height. So we'll get 1. Remember, this is these two areas are negative because they're below the x-axis. So this is going to be -9 plus -3/2 plus 1 equals 3 minus our f of -5. Good, so we're getting somewhere. Our only variable left is the f of -5. So that means we're going to do -9 plus -3/2, that's -10.5, plus 1, that's -9.5. We're going to subtract 3 on both sides, get negative f of -5. That's going to be -12.5 equals negative f of -5. And since they're both negative, the negatives cancel out, and we're left with f of -5 equals 12.5. And that is your solution for A. All right, so let's take a look at question B. Question B just wants us to do the integration from 1 to 6 of g of x. Well, remember, that's going to be so from 1 to 6. That's all of this area. And we can see that that's kind of broken off into 2 segments as well. So that's going to be from 1 to 3, uses the vertical line there, the horizontal line there. And then from 3 to 6 is going to be our function that they gave us right here. So the integration from 1 to 6 of g of x is going to be the integration from 1 to 3, that's our square portion, plus the integration from 3 to 6 of g of x. So this first part here is just a 2 by 2 square. That's going to be 4. Plus our integration here is going to be the integration of our function. 2 x minus 4 squared dx. Now there's a little trick here to solving these integrations where our x is inside parentheses and has an exponent of 1. There's an invisible 1 here. We can use our little trick, our shortcut. So this is going to be 4. We can just treat it with the u substitution. So that means our new exponent is going to be 3 and divide by the new exponent. And that's going to be from 3 to 6. That's going to be 4 plus 2/3. I'm going to take out the 2/3. This is going to be 6 minus 4 cubed plus, subtraction, always subtraction, plus 3 minus 4 cubed. So that's 4 plus 2/3, 2 cubed minus -1 cubed. So that's 4 plus 2/3, 8. So triple -1 and then another -1 makes it positive. So that's 4 plus 2/3 times 9. That's 4 plus 18/3. That's 4 plus 6, and that will give you 10. And that is your solution for part B. Let's take a look at part C. Part C asks us for -5 to 6 on what open intervals, if any, is the graph of f both increasing and concave up. So if you remember, increasing means your first derivative is positive, and concave up means your second derivative is positive. So we're going to do a domain chart. We're going to do a domain chart to help us easily identify what's positive and what's negative. And they want the graph of f, so looking at f prime and f double prime. And they give us some nice boundaries here. So we have -5. I'm picking from my graph. -2, -1, 0, all of these little points where it's a corner or such. 1, 3. Now you want to be careful. We have a min here. Those are important. So we're going to throw that in there too. 4 and 6. Okay. So since this is a graph of G, meaning also a graph of f prime, we're going to be positive wherever we're above the x-axis, and we're going to be negative wherever we're below the x-axis. So this is where everywhere the f prime of x is greater than 0. This would be everywhere the f prime of x is less than 0. So we can see from -5 on, we don't know. They don't give me any information over here. Same thing with greater than 6. We don't really know what's going on over there. But we can see that I'm going to be negative from -5 to -2, -2 to -1, and then from -1 to 0, we're actually just going to be 0. And then from here on out, we have positive values. Again, we don't know what's going to happen after 6. For all we know, it just jumps up and keeps going. We don't know. It doesn't matter. And so now, when we want to find where f double prime is 0, well, that's the g prime. That's just f double prime is just g prime. So we're going to look at the slopes of the function. If the slope of the function is positive, that means our g prime of x, which is f double prime of x, is greater than 0. And if our slope is going negative, that means our g prime of x, which is f double prime of x, is less than 0. So we can see we actually start off with a horizontal line. So that means, again, we don't know what's going on before -5. But from -5 to -2, we can see it actually has a slope of 0, a nice horizontal line. Then it starts climbing up. Then it levels off to 0 again. But then it starts climbing up again. Then goes 0. Then it drops down. Then it climbs back up. And then we don't know what happens with it after 6. So then where is it increasing and concave up? Well, that means positive on top and the bottom. That's going to be between 0 and 1 and between 4 and 6. So for question C, f of x is both increasing and concave up on the intervals 0 is less than or equal to x is less than or equal to 1, and 4 is less than or equal to x is less than or equal to 6. And that would be your answer for question C. All right, now let's take a look at question D. Before I erase, I'm going to read what it says to see if this work will help me answer the next question. Find the x-coordinate of each point of inflection of the graph of f. Point of inflections have to deal with our domain check, so we don't have to delete anything. All of our work's actually been done. We just have to do our analysis. So the point of inflection for f just means that f double prime of x switches either positive to negative or negative to positive. We can see that our f double prime of x, 0 to positive, no, positive, 0, 0, positive, positive, 0, no. The only time that we switch either from positive to negative or negative to positive is at 4. That means f has, let's do a different color, let's do blue. So f has a point of inflection at x equals 4. Now they want an answer. I'm going to write that over on the side. Because f double prime of x switches from negative to positive at x equals 4. And that would be your answer. So I know I've been erasing and other things like that. Remember, I have the written solutions down in the Files tab under Microsoft Teams. This is it for question 1 on Classwork 1. Check the other videos for question 2 on Classwork 1.